All right, guys. So today we are starting our 2.1e function transformations. Okay. This is actually a three-part note. So today we're probably only gonna have enough time to get through part one. Then tomorrow's goal is to do part 2 and part 3. Okay. And then on Friday, you have a Canvas assignment that you're going to complete over 2.1e. Okay. Remember, you were giving your review already. That's because when we come back from the break, that Monday we get back, you will be working on your review. We'll have an in-class review day where you ask me questions and work with your peers. And then we take our test on Tuesday. And that's it for 2.1. Okay. But this is the last part, 2.1e, function transformations. So here we go. All right, for part one, this is not in your notes that you have. On part one, we're going to talk about using graphs, finding the vertical and horizontal shifts. Sorry, I had a little brain fart right there. Finding the vertical and horizontal shift. Right here, this is called function notation. Okay, this means that these rules apply to any function. Does that make sense? It doesn't matter whether it's linear, quadratic, absolute. It doesn't matter because it's in function notation. It applies to all functions. Does that got it? All right. So we're going to talk about vertical transformation and horizontal transformation. Vertical is telling you how much up and down you're going. Horizontal tells you how much left and right you're going to go. Got it? All right. So let's dive in a little deeper of what takes place. When you have a vertical shift, if A is a positive number, so K is going to be a positive real number. What that means is that you're going to be adding to your Y values. So f of x plus K is going to cause my graph to shift up K units. So to each Y value, I am adding whatever K is. So you add whatever numbers outside of the function, that's what you're adding to Y. So it's Y plus your K. Okay. Hopefully y'all remember some of this. Okay. That's going to cause us to go up. F of x minus K is going to cause us to go down, which means that mathematically we have our Y's and we're subtracting. Okay. When we're referring to the Y's, we're referring to the Y's of our parent function. Okay, so that's vertical shift. Now we're going to talk about horizontal shift. We're going to talk about horizontal shift. Now, for horizontal shift, I want you to write that X's are liars. That's why they're X's. Okay. When you have the X, you are replaced by X minus H, and H is going to be positive. H is already positive. So even though it says X minus, your H is already positive. Okay. So when we have this, Y equals F of X minus H, that's going to cause us go to the right. The only way you can move a whole function to the right is by adding to your X's, right? If I want to go to the right, that tells me I have to add to my X values. Does that make sense? Even though it looks like I am subtracting, what am I actually doing? Adding that value to all of my X values. Okay? Now, when we have Y equals X plus H, and it says you're shifting to the left, the only way mathematically I can shift to the left is subtract from the X values. That's why we say our X's are liars, because we look at it like, oh, instantly, you went to the left. I subtracted. No. When it says X minus H, it actually went to the right. Okay? When it says X plus H, it actually wants your function to go to the left. Your X's are liars. Okay? All right, are you ready for some examples? Okay, so we're going to look at it from a table perspective and from a graphic perspective. Okay, to start with, we have our function f of x equals x squared. F of x equals x squared is what we call our quadratic parent function. So this is our quadratic parent function. How do I know it's quadratic? The square. The square tells me that it's quadratic, okay? It's called our parent function because nothing is being added, subtracted, multiplied to the x or the function as a whole, right? It's the original. It's the OG, okay? It's ground zero. However you want to think about it, that's my parent function, okay? All right, so for the parent function, we have initial values that we start off with. And they're always the smallest that make the shape of your parent function. What shape are we trying to make? A parabola, right? We're trying to make a parabola, that U shape, right? So my values that we use to make our U shape are going to always be -3, -2, 0, 1, 2. I skipped a whole number, y'all. -1. I don't know where it went. Okay. So those are my x values. How do I find my y values of my parent function? I'm going to plug them in. So what is -3 squared? 9. What is -2 squared? What is -1 squared? What is 0 squared? What's 1 squared? 2 squared. And 3 squared? 9. These are the values that help me create my function on a graph, right? So this is my table representation. Now we're going to make our graph representation. So take this moment, plot your points, and create your parabola. It's all right. You just tell yourself it's the best in the world. That was like these. Well, I need to put a little curve on it, I guess. But all right. So again, these are our parent functions. So anytime there's a transformation and I need to create a graph, this is where it's coming from. Does that make sense? For quadratic. Because there's other functions. Quadratic isn't the only function. All right. Now I'm going to switch colors. If you have another color, which is, or you can share colors at your table or switch to a pen or whatever you're going to do. Now we're going to talk about g of x. So g of x is x squared plus 2. Okay. What did we say if I'm adding to the function? So if I'm adding to the whole function, what does that mean it's doing? It's going up. The whole function means it's going up, right? It's x squared plus 2. So that means that I'm going to have to shift this whole thing up. So I'm making a new function and it's going to be shifted up. In order to shift up, what variable am I changing? X or Y? Y. So because I'm going up, I'm going to change my Y's. Does that make sense? So g of x is telling me to each one of my original Y values, I'm going to have to add how much? 2. So to the originals, I'm adding 2. So it's going to be 9 plus 2, 4 plus 2, 1 plus 2, 0 plus 2. And that's going to give me 11, 6, 3, and 2. Those values are going to repeat. That's not a 3. I tried to make it. It's ugly. Tried it. So then it's going to be 3, 6, and 11. So if I use my original x's, because did I change my x values of my parent function? No. Okay. I like to think about this. You have parents, right? And your parents in this situation are X and Y. Sometimes you look more like your mom. Sometimes you look more like your dad. In this case, I'm going to look more like my mom. So I'm going to keep my X's, but change my Y's. So now I'm going to be at -3. That's going to be off, right? -311. I'm now at -2, 6. -1, 3. 0, 2, and I'm going to repeat it on the other side. So here's my g of x. And there's g of x. Did by adding 2 to my y values do what g of x said to do? Yes? Yeah? Okay. All right. Change colors again. All right. This time we have h of x. And h of x says x squared minus 2. So based on what we said, what does h of x want us to do?
Go down.
It wants us to go down to. Why? Because it says minus on the outside. If I want to go down, then that means I'm also changing my y's. What am I doing to the y's? Subtracting 2. So to all of my y's of my parent function, I am going to subtract 2. Going back to 9. So it's 9 minus 2, 4 minus 2, 1 minus 2, 0 minus 2. And that's going to give me 7, 2, -1, -2, and it's going to repeat -1, 2, and 7. I'm going to use the same x because we look more like our mom. So that's going to stay the same. And now we're at -3 is now at 6, right? 1, 2, 3, 4, 5, 6. -2 is now at 2. -1 is now at -1. 0's at -2. I'm going to repeat it on the other side. And here is my h of x. The rebel, the one shifted down. That went bad. Okay, how do we feel about vertical shifts? Doable? Yeah?
That's why I bring that one down 3.
Huh?
So why you bring that one down 3?
Bring what down 3?
That one?
I did not bring it. It's all based on the parent function. I did not bring it down 3. I brought it down 2.
How? Because that one, that is way up there. Shouldn't we go in here?
Oh, did I put my dot in the wrong spot?
Yeah.
Bicycles. I miscounted 6. It's just a really big dot.
Oh.
What are you talking about? Yeah. What are you talking about? It's really big. Why'd you wait till I finished, Justin?
I didn't notice until I started doing it.
Okay. All right, let's talk about the domain. What's the domain? Do all the graphs go forever to the left and the right?
Yeah.
Yes. So the domain in all of these is what? All real numbers, right? What changes for them though?
Why?
The y's. So when I look at the red graph, what is my range? Where do I start? 0. So my y's are greater than or equal to 0. When I look at g of x, my purple graph, where does it start? At 2. So my domain, my range is y is greater than or equal to 2. When I look at h of x, my green graph, where is it at? It starts at -2. So my range changed, but my domain stayed the same. Okay, how do we feel about vertical? Okay, vertical, we're good? All right. You know what I meant. All right, next, we put, can you, I forgot to update it. Just cross out where it says, it's just all horizontal shifts. All right, so again, we're going to quickly do our parent function. This time though, what is it? It's absolute value. Okay, this time our parent function is absolute value. Absolute value is very, very similar to quadratic, right? Okay, the shape, instead of a U, we make what? A V. And because of that, our starting values are going to still be -3, -2, -1, 0, 1, and 2, 3. Okay, the difference is our output, right? So our difference is going to be our output. So if I take -3 and I input it into the absolute value, it's going to do what? Turn positive. So the output for f of x is going to be 3, 2, 1, 0, 1, 2, 3. And I'm going to quickly sketch the parent function.
Okay, this positive is really positive.
If it's positive, it just stays positive. If someone has a positive attitude, why would you want to change it?
This means that is.
You want to be negative Nancy? Get out of here, negative Nancy. All right, that's the best you're gonna get out of me, guys. All right. Changing my color. Now let's look at our g of x. Our g of x says absolute value of x minus 3. What did we say about our x's? Our x's are liars. So it looks like it wants us to go to the left, but it actually wants us to go where? To the right. The toxic. Couldn't say that word with a stuffed up nose. It's really hard. Right? It wants us to go right. Mathematically, in order to go to the right, what do we have to do? We're going to have to add to our x's. So this time we're changing our x's. So these functions are going to look more like their father. Okay? Because we're now only changing the x's. So for g of x, we're going to change the x. And what are we doing to each one of our x's? We're adding 3. Because we want to move the function to the right. Does that make sense? Okay, so to each one of these, I'm going to get -3 plus 3, -2 plus 3, -1 plus 3, 0 plus 3, 1 plus 3, 2 plus 3, and 3 plus 3. And what do I get? We have 0, 1, 2, 3, 4, 5, 6. Okay. So now when I graph, these are my new x's and my y's are going to stay the same because I'm not going up or down or anything, right? I'm only shifting it to the right. So now I'm starting at 0, 3. I'm going to 1, 2. I'm going to 2, 1, 3, 0, 4, 1, 5, 2, 6, 3. And did I shift my parent function to the right?
Oh, okay. I see it now. I see it.
Do we see it?
What? I see it. You can that have the g of x with the f of x.
Yes, your parent function.
G of x, the y values are the same. So that's your new x value, not y.
So these are my new x values exactly. That's why it was x plus 3.
Wait.
Because our goal was to do what to our parent function? Move it to the right. And if I change the y's, is that going to cause me to go to the right? No. That's going to cause me to go up and down. All right. Now let's look at h of x. This is our last piece for today. Looking at h of x, what does it want us to do? It wants us to go to the left because our x's are liars. It actually wants us to go to the left. If I want to go to the left, that means I have to move my x. What am I now doing to my x's? We're going to subtract them, right? So for h of x, it's telling us to each one of our x's, we're going to subtract 3. So going back to my parent function. So we have -3 minus 3, -2 minus 3, -1 minus 3, 0 minus 3. We don't touch the absolute value at all. 1 minus 3, 2 minus 3, and 3 minus 3. The beauty of using transformations is that you don't have to actually plug the values into the function. You're just manipulating the parent function. So we get -6, -5, -4, -3, -2, -1, and 0. My input can be negative with absolute value. It's just my output cannot be negative. And are we changing our output? No, these functions look more like their father. So no, we're not. So now I'm going to start at -6, 3. So 1, 2, 3, 4, 5, 6. And I'm going to go up to 3. 1, 2, 3. Then I'm at -5, 2, -4, 1, -3, 0, -2, 1, -1, 2, and 0, 3. Did we move our parent function to the left? Yeah. Okay. Did the domains and range change? No, for all of them. What's the domain? All real numbers still. Oh, whoa, how we got there? I don't know. I clicked too quickly, guys. My bad. So our domain is still all real numbers. And what's our range for all of them? 0. Y is greater than or equal to 0. Okay. How do you feel about vertical and horizontal shifts?
Good.
Good? Doable? All right. So tomorrow we'll be doing parts 2 and 3.